Well, here we are at the 67th annual SPWLA symposium. This is the poster session, day one. We have our first presenter. Please introduce yourself and let's talk about this poster.
My name is Ahmed Dawad. I'm from Halliburton, Kuwait. I'm here to represent the Geosteering and ultra-thin reservoir using the high-definition deep LWD tool in order to reservoir. So here we have some of the rarest case. We don't see much in Kuwait. So drilling an ultra-thin reservoir within 6 to 8 feet thickness was an extremely high or hard drilling expertise. So utilizing.
One second. So you're drilling the drill bit's drilling through horizontal. You have a tool that's going out and measuring resistivity around and in front of the well. It's
not in the front of the well.
Around it. Okay.
So let's say if it was 40 feet behind. So over here, as we can see, the target was to drill within 6 to 8 feet layer thickness. So we wanted to stay within the reservoir contact the whole time, which was a thickness of the narrow thickness of around 10 TVD. So as we can see here, we landed the well 7 feet across from the top boundary. And then we try to stay within the reservoir the whole time. So in order for us to achieve this, or to be able to stay within the reservoir, utilizing the new technologies of the azimuthal deep resistivity with the tilted antennas that help us to get a better detection or a better inversion.
These color changes along the wellbore are...
The color changes is the resistivity contrast. Yes, this is the tool seeing it real time.
Target's oscillating like this?
Yes, this is the total, this is where the resistivity target is. That's where the customer wanted to stay within this resistivity contrast, the green one, or the lower resistivity comparing to the top and bottom higher resistivity contrast.
Wow, that's interesting how the resistivity has like a...
Yes.
It's almost like it's coming from somewhere.
Yes, exactly. And then with the dip variation in these wells, during drilling horizontally, the dip variation is changing. So you can see here that once we started drilling, we saw that we are getting closer to the boundary down, which is the higher resistivity. Then with the geosteering started to give the introduction to start going up. And then while climbing, they saw the thickness is getting lower. So they needed to adjust again. So it was more of a proactive geosteering due to the dip calculation that we were able to get. So the key message here was using this azimuthal tool. It will help a lot to be able to geosteer and geomap the target reservoir. We achieved here to stay within 100% of the target reservoir. Thank you so much.
Man, thank you. That was well done. Fast. You've got your resistivity stuff on track. That's a very interesting way to visualize what's going on. Have you guys done much on how to change the visualization so it looks like a lithology, or do you just keep it in like a hot and cold color?
We can change the color based on the scales that we needed to see the resistivity contrast that we have. But like over here as well, we have the density image as well. You can see that was another thing, but we didn't see much of a changes in it. So that's why it was not going to be very useful to stay within the target. So that's what is differentiating the new technologies now. These wells used to be drilling using the density only, like density image. But now with the resistivity image and the resistivity tool, it's making more sense.
Are you seeing operators use this in areas where they have really good well control, or they don't have really good well control where they use this, or both?
Actually, you see it in both sides. It's an advantage tool to use it in both. Like this is one of the mature development teams that we have. It's not like the area is not new on us or anything. But we saw the differences in the layer changing. That was, in order for us to maximize the reservoir contact, we needed to have these sort of technologies. But if you just want to drill the well, you can go ahead with the conventionals. But in order for you to maximize your reservoir, make sure you are in contact with the reservoir the whole time, you need these sort of technology.
The resistivity is so obvious as you're running.
Yes, and now it's becoming with the 3D models and 1D model, and it's getting much better and every day. So we're learning as we go. And thanks a lot for the SWA.
Let's get a picture.
Yep.